Is the trapezoid of excellence a legitimate basketball metric, or does it not actually mean anything? By the end of this video, you're going to know exactly what the most popular graph in college basketball, the trapezoid of excellence, is, what it means, and whether or not it can actually help us accurately predict who's going to win games in March Madness. But first, we need to understand what we are actually looking at. The trapezoid of excellence is formed by two key things: the opponent adjusted net rating on the vertical side, and then the pace of play of each team on the horizontal side. Now, the first part of that equation sounds really fancy, but it's actually pretty simple. If you're doing better on offense than the other team is doing when you're on defense, even after accounting for how good the team is, then you'll be higher up on the chart. In other words, if you're good at basketball, you will be higher up. If you're bad, you will be lower. And that's where the horizontal part of this equation comes in. According to Ryan Hammer, who created this visualization, teams that play either way too fast or way too slow will not do as good as teams in this Goldilocks zone in the middle in that trapezoid, even if they are as good a team. In other words, let's say two teams both have an adjusted net rating that's pretty good. Well, if one team is way too fast and the other team is totally average in pace, then the normal paced team is going to do better. That's what the trapezoid theory kind of explains. But I don't think anybody's actually ever tested it. So today in this video, we are going to test and answer the question, does this actually show up in real March Madness data, or is this just a cool shape? Now, in order to test this, we need to answer one key question. Does pace of play, the horizontal part of this chart, actually matter after you account for how good a team is? To answer this, I analyzed 15 years of March Madness data across 1,024 different teams, specifically looking at how many games each of these teams won in the tournament, which means for this experiment, I'm excluding the first four round. We are only looking at the group of 64 on. Now, for starters, we need to confirm that the actual opponent adjusted net rating is a half decent predictor of how many games you're going to win in March Madness. And as you can see with this kind of loose correlation, again, it's hard to be perfect because this is real March Madness data. There is a pretty clear relationship between how good in adjusted net rating you are and how many games you're going to win in March Madness. But what about pace of play? Well, when you look at pace of play compared to number of wins, it looks like there is no relationship whatsoever. Whether you are way too fast or way too slow, it doesn't look like there's a clear relationship just looking at pace of play. But that's not the goal of this experiment. We need to look at pace of play after accounting for that net rating. The real question is, does pace of play give us better predictions after accounting for net rating, not pace of play by itself? And after checking that perspective from a couple different ways, it is very clear it does not. Once you know a team's adjusted net rating or how good they've performed during the season, knowing their pace of play adds zero predictive value to how many games they're going to win in March Madness. But rather than just throw the raw numbers at you, let me actually show you. So this first set of box plots is going to show how our predicted number of wins for a team is actually showing up with how many games they actually won. And this is built just with adjusted net rating. So each box is how many wins a team actually had in March Madness, and how high or low they are is how many wins we thought they were going to get. So luckily, if you look at these boxes, there's that little line in the middle that represents the average, and it does look to be pretty clear. When we expect them to win more games, they actually do win more games. I know it's not a perfect relationship, but the correlation is there. Now here's what's crazy. Let me flip this graph to a different one. And let me go back to the first one, and let me show you the new one, and let me go back to the first one, and let me show you the new one. You see how little it changed? The difference between the two graphs is whether or not we accounted for pace of play. So look at this, adjusted net rating right here, adjusted net rating and pace of play right here. You see how little it changed? You see how little of an impact pace of play is making on our actual predictions? What we found is that pace of play is not statistically significant. From a data science perspective, what this means is once we know the team's opponent adjusted net rating, adding in pace of play, or even how different their pace of play is from the average to help account for fast teams and slow teams, no matter what you add, it gives us no extra information, no useful information to predict how many games are going to win in March Madness. So already I am hesitant about that trapezoid. But you know what? Let's take it a step further. Let's actually recreate the trapezoid graph itself. Here we could just visually test and see, are the people inside the trapezoid winning more games than the people outside of it? So now what we're seeing is every single team in the 15 years of March Madness data we have is a different point on this graph, and we're going to color them by how many games they won in March Madness. And before I throw the actual shape on the screen, it's pretty clear. Like there's not a real relationship here, right? I mean, the teams that are higher up, we're seeing a little bit more green, obviously plenty of red for the Ohio States of the world that were like a 2 seed and lost in the first round. But for the most part, it doesn't look to be like there's this golden trapezoid part in the middle. In fact, when we add a trapezoid in the middle to represent teams that are pretty good in opponent adjusted net rating and not too fast and not too slow, what if we compare the teams in that trapezoid to teams that are just as talented, in other words, above that black line in opponent adjusted net rating, but are very fast or very slow? Is there any difference there? I mean, visually, to me, it doesn't look to be like there's that much of a difference, but let's not just rely on visuals. The average amount of games that the trapezoid teams won in March Madness is almost the exact same as the other good teams that fall outside of the trapezoid. Now, sure, the teams below that black line didn't win nearly as many games, but that's because those teams are just worse. Again, we're not looking at bad teams versus trapezoid teams. We're looking at trapezoid teams versus teams that are just as good, but way too fast or way too slow. Because that's the whole point of the trapezoid, is to, segment out the teams that play way too fast or way too slow. So now we've looked at it from 3 different perspectives. From a statistical term, the pace of play addition doesn't seem to help us predict how many games a team is going to win after you know their actual opponent adjusted net rating. From a prediction standpoint, we saw that our predictions hardly change at all, even when accounting for the pace of play. And finally, from an actual trapezoid perspective, in the past 15 years of valid March Madness data, teams inside of this trapezoid are winning just as many games as teams outside that are playing way too fast or way too slow. The bottom line here is, if you want to predict who's going to win games in March Madness, I am not going to care about pace of play, okay? If you are higher up on this graph, you're good at basketball, you've played good at basketball over the course of the season, and unsurprisingly, being good at basketball is what really matters at the end of the day in winning March Madness games. I still love the chart, I still love the value it brings, and it's very cool to visually kind of understand who is good and fast versus bad and fast, and good and slow versus bad and slow. But this is a descriptive statistic. The goal here is to kind of describe what's going on here. This is not predictive, okay? We should not be using this trapezoid to predict who's going to win games, because at the end of the day, we have shown in this video that the trapezoid of excellence is not a good predictor of March Madness games. Just pick the teams that are good at basketball. I'm sorry that was the boring conclusion of this video, but I had a blast. This is also going to be the very first ever post on this channel, so no better way than directly attacking the most popular graph in all of college basketball. I didn't mean to do that, but just was really curious on it. But if you liked this video and you want to see similar things of taking a deeper dive into sports with an analytics perspective, let me know what else you want to see in the comments. Also, if this is something you disagree with, would love to know the reason why and get your thoughts in the comments as well. Again, I'm clearly very new to this. If you look at the channel right now, there's no other videos. So I appreciate you watching. Hope everybody has a great bracket. And if you want a great bracket, don't follow the trapezoid this year. That's all I got. Peace out.